Hello, everybody. Wonderful. Welcome to Sunday here at Joe's Computer Museum. We're going to sit back and relax for a couple minutes, chat about what we're going to be doing tonight before we get started and let some people roll in. If this is the first time you've ever been to one of my streams, hello and thank you for stopping by. If you've been here before, welcome back. So tonight, what we're going to be working on is the Replica 1 from Vince Briel Computers, as sold and distributed by Henry Corbus of Retro Reactive Micro. Cool little kit that basically recreates the Apple I. It's one of the quickest, easiest, simplest ways to get an Apple I-like computer to be able to experience that without spending $1 million on trying to find one at auction, because that would be crazy. So that's basically what we're going to be doing tonight. I hope you all enjoy it when we sit back and relax and just do some super chill soldering. So before we get started, of course, if you don't know, I do have a little shop where you can buy cool things like this drinking mug or this 8 bits are all you need t-shirt. If that's something you like and want to support my museum and help keep my shelves stocked, you can do that. You can get those at jcm-1.com. And tonight's beverage of choice is a simple black tea with cream and sugar in it. So deliciousness. Yummy. Stand by for just a second. I need to play with my settings because for some reason I don't see the live chat going on my screen. It's screwed up, so I'm going to have to find that. YouTube has been doing some weird things lately with stuff. I don't know why exactly, but it is a thing. So I have to bring up my own live stream on my own, I don't know why my stream console isn't showing it. Do this, and then I'm going to mute that, and then there's the chat. There they are. Joel Mick, hello Joe, hello to you. Cold solder joints, not missing much. Yeah, it's pretty, the chat's pretty light right now. Amart USA, hey Joe, hey to you too, how you doing? So I can actually see chat now, that's great. Let's do pop-out chat, make it full screen so I can see. That's better. Now I can actually read things. So we're going to go ahead and get this switched over. So let me change to the bench. And here is the bench. And let's get started. So this is the kit. Comes from Reactive Micro. It's Vince Briel's design. Does not come with the instructions built in because, look at it. It's like a whole bunch, so it's like 15, 20 pages. So if you want your instructions, you have to go to the Reactive Micro wiki, download and print that if you like, but that's no big deal. That's not the end of the world. Henry, as always, does an insanely excellent job of packing stuff up, all in individual baggies, with individual, what do you want to call it, foam pieces to keep all the pins from bending. Everything comes in a static bag, so that is awesome too. Everything's shipped proper and protected. From a seller as experienced and as kick butt as Henry, I would expect nothing less. So he does a really good job on that. So here are all the bits and pieces. I'm gonna, spare you all the boring stuff of what all this is, but basically, you've got the board here, the main board. It even has the socket connection, so you can use authentic Apple I peripheral devices if you want, and then it comes with all of the bits and pieces. So without further ado, I'm just going to start throwing it together, and we can sit back, chat, and watch as I do the stuff. So Randall Cook says, morning. Yes. Amart USA is Anthony. Hey Anthony, how you doing? Henry Smith, I think, is actually the seller of this product, if memory serves. And Randall says, good morning. Are you on the other side of the planet, Randall? I presume that you're in Australia? Something like that, maybe? So let's go ahead and get this together. Now, typically when doing boards like this, you go from the smallest components to the largest components. the ones that are closer to the board, and then on your way up. So you can pre-populate the board, flip it over, and they all sit level while you solder it on the back of the board. And that's basically the same thing I'm going to do here. And I'm going to start with things like the resistors, diodes, and stuff like that. The cool thing about this is every single one of these components is specifically marked as to what the component is. So all the resistors have their values marked and everything, so I can just fetch through here, find the thing, stick it on there, and solder it. So easy peasy. So let's start with these 3.3K resistors because I see a whole bunch of them here, and I've got some here. And here's a trick I like to do for getting resistors out of the blister packs. I like to just use a pair of scissors, and you can just cut the ends right off of them. You don't have to futz around with the super stupid paper tape and stuff. You just, there they are. Now these are 3.3s, so they go in there. 3, 3, 0, and 1, 0. 3,300. Yep, that's it. So we take these. I'm going to put them right through the holes there. And repeat this a whole bunch of times until they're done. .3, another 3.3. Now there actually are cool tools you can use to pre-form and cut these leads. If that's your fancy, you can do that. I also tend to be a stickler for trying to get the color codes all in the same orientation, just because, you know, of fake OCD, not real OCD. You know, there's just, they have to be the same direction or it bothers me. But sometimes I'll get going and I'll get one backwards. I won't realize until it's assembled, and then I get all upset, but you know, whatever. There we go. Those are in there. So do we have any other 3.3s? We got one up here. While we're doing these resistors, I'll talk about resistor color codes a little bit if you're not familiar with color codes. Australia, yes, hello. Most users won't need the install guide because it's a good review course. Of course, yes, the install guide is very insanely thorough, so that's good. Speaking of that, need to go to the other side of the planet for a good morning. Past 5 midnight should qualify. Ha! Yeah, let's talk about resistor color codes. If you're not familiar with resistor color codes, they're pretty easy to understand. The idea is that it is a spectrum of colors that goes from black all the way through white. So it's black, brown, red, orange, so on and so forth. And those represent the numbers 0 through 9, respectively. So when you read your color codes, you just read the codes across in order, with the last one remembering that it is a multiplier, and you think of that to be the number of zeros. So in this case, this one's hard to read, but it's orange, orange, black, brown. So that's 3, 3, 0, and then brown is 1. That means there's 1 0, so that's 3,300 ohms or 3.3K. So that helps you read those codes. Another 3.3 we got over here. And so once you kind of learned how those color codes work, you can, you know, you dump a bunch of resistors on the bench, you'll be able to read them, sort them, and be hunky-dory with that. You can also do the thing where you can put all of the 3.3, all of the 3.3s or 2.2s or 5.6 value resistors all in one bin to save space on the number of bins that you're going to be using. And then because you know you can read your color values, you'll be able to just look in the bin and find the one you want to save space, if space is at a premium for you. Now I have one extra resistor, and I am just double checking to make sure I am not missing it anywhere. I am. It goes right here. Sometimes kits will come with extra resistors, or in the case of me sending out my lead bright kits, I usually miscount, and you get extra stuff anyway, just because I miscount. Better to miscount too many than not enough, but you know, whatever. So now that all of those resistors are in, we flip it over and we start soldering. This is my favorite solder. This is the Kester Rosin Core 6337. Pretty standard stuff. It does a really good job. it affixes well, and it's a low clean solder. So even though it does leave some residue, it doesn't go all over the place typically. So let's get this going. Now I'm going to, I messed up on this first one, but I'm going to go through all of these and solder one side to and then make sure that the resistor is planted properly in the hole and it shows up, or it's sitting properly against the board before I solder the other side. And that's just, again, an aesthetic thing. You don't really have to do that, but if you want your board to look nice, that's something you'll want to do. So they're all in there, and they're all nice and flush with the board, and they look good. Yes, now we can do the other sides. In theory, it doesn't really matter if you do the whole solder one pin, align, and solder the rest of the pins. As long as the solder has actually taken, it's not that big of a deal. It's just an aesthetic thing, but some folks, they like it to look good. The aesthetics are important. Okay. Oops, I missed one. You can do it. There we go. About the tools I'm using, I am using what's called a KSGER, I don't know what it is, KSGER soldering iron, or solder station really, set at 390 Celsius. That is my preferred temperature, seems to work well. I have a kind of a chisel-y tip on there because it's got a point on it that allows me to get in and do fine work if I need to, but it also has a nice fat edge for tapping the solder on and getting it to melt really easy. I just got that thing at Amazon. You can get them as kits on Amazon for like 79 bucks, and it comes with all of the tips. It takes standard Hakko T12 tips, and it costs less than a Hakko does. So it's a win all around. I've been using it for about 2 years now, and the thing just frigging works. It's got a standby mode. It's got vibration or pickup detection. So if it's asleep but not fully standby, you can pick it up and it will heat back up on its own. So it's good to just like turn it on and leave it sitting in the corner. That's almost kind of how I do it. I almost never turn the thing off. It just sits there and runs in the background. When I'm ready to use it, I pick it up, wait 5 seconds, and it's heated up and ready to go. So what's next? What other resistors do we have in here? Let's see. Here we go. 1K resistors, 1,000 ohms, and if we look at those, it's kind of hard. The blue ones are kind of hard to see, but it's brown, black, black, brown. So that's 100 and 10, or 1,000. So cut off the tape. Alrighty, let's get the 1Ks in. 100. Yep, it goes this way. What's chat talking about? Color codes for resistors and how to ID a diode and caps. Yeah. We'll talk about capacitors and things here in a moment as well when we start to get into those. Capacitors are interesting. You have to be careful with those because some are polarized and some are not. A resistor is a non-polarized element. It's a non-polarized passive component. It can go in the hole anyway. It does not matter. It does not care. It does not discriminate. However, looking for any more 1Ks, but I don't see any, so I think this might be a case of we just got a whole bunch of extras. Could be. Yes, I'm pretty sure that's the case. But some capacitors are polarized, which means that they have to go in a particular direction, or else bad things happen. Like at best case scenario, they don't function. Worst case scenario, smoke, fire, and explosions. Which, if you're watching for entertainment value and you're watching me screw it up, that's fun. You get to watch things blow up. If you're doing it for yourself, it's a little scary and a little bit of annoying because then you gotta desolder it and replace it and all of that magic. So we'll do the 1Ks here. Diodes, of course. Oh, hold on. Parts overboard. Diodes, of course, are a polarized element because they only conduct electricity in one direction. They are a one-way valve or a reed valve, of course. And those are you have to pay attention to a specific direction. Oh, here's all the 1Ks. I missed them. Ah! Whole bunch of them. But yeah, diodes have to go in a specific direction. If you put it in the wrong way, your circuit, depending on where it is in the circuit, nothing bad will happen, it just won't function. But if it's in a particularly high voltage part of the circuit or a high current part of the circuit, you may break its reverse bias voltage and bad things can occur. LEDs, when reverse biased, have a habit of failing. Of course, an LED being a light emitting diode, which is just a special diode that emits light. So yeah, you have to be careful to watch your polarity on those. LEDs are actually pretty easy to determine the polarity on. They have the different pins on the LED will typically, if it's a standard LED like this one, you'll notice that one of the legs is longer than the other. The long leg is the positive end. And the mnemonic I like to think of is when remembering that is positive is more than negative and long is more than short. So the positive end is the long end. So when you're putting those in, those have to be put in the correct direction. Of course, your integrated circuits are also a polarized part, or really they're an indexed part. You can put those in backwards and bad things will occur there as well. Typically the part will get really, really, really hot, and depending on the amount of current where that part is, the manufacturing technique used to create the part, and other things, this part may actually catch fire and cause smoke. Again, super entertaining for you to watch me do, but not entertaining for yourself. I was actually working on another unrelated project earlier today, just doing some stuff behind the scenes, and got a chip in backwards, and boy did that thing get hot, but it didn't break the chip, so whatever. Does the solder also give off the magic smoke? Yes. Yes, the solder gives off magic smoke. I am a solder non-purist. I don't care if the smoke gets all over the place. But for proper safety's sake, you usually want to have some sort of smoke extraction system. But that's the special. This is the special kind of magic smoke. This is the good magic smoke, where if you see it, good things are happening. That means a metal is bonding and your parts are getting put in. You don't want to see the magic smoke when you put in something backwards, because that means you have to replace something. I hope everybody can hear me okay. I'm not facing the microphone, and I've got a very, very, very noisy air handler unit over here that is basically on 24/7, 365 because Ohio and July. So if you're having problems hearing me, let me know. I will yell louder. I'm going to get all the 1K resistors put in here. As you see, this rosin core solder, it doesn't leave a lot of gunk all over the place. It leaves a little bit, but it's pretty clean. It's billed kind of as a no clean solder, which is cool. When you're putting together quick projects and stuff, it's really helpful. Cut the leads off. If you haven't watched my my streams before, I always mention to keep some of these little wire leads when you're cutting components. They are very helpful for doing bridge overs, when doing links and doing quick bodge repairs and stuff like that. They're helpful to have around. I have a quadrillion of them at the moment, so I don't need them, so I'm just kind of scooping them up and getting them out of my way so that they don't muck up my work surface, but good thing to keep them around. Okay, those are the 1K resistors. Those look good. Yes. Yes, most of the smoke in that is rosin. Most of the smoke in just about any of your solder is going to be your rosin or your flux as it vaporizes or boils away. I like the Radio Shack 15-watt soldering iron. It takes about an hour to heat up, and you can use an ashtray as a stand. Oh, heck yeah. Yeah, baby. I still have ancient soldering iron solder from back in the day, from when I had one of those soldering irons. I've had this old solder around since about 1990 or so, and I keep it as a constant reminder of bad products. When soldering, if you smell something like chicken, you are holding the iron incorrectly. This is true. Nice snips, yes. The snips I'm using are 170 style, as they're called, Exolites by Weller. I happen to like them. They work really well. I've run through some cheaper knockoff snips, and they just don't work as well. They don't cut things flush. The Wellers do a really good job of cutting things nice and even against the board. The cheaper snips have a tendency to leave super sharp edges on the back of the board, and if you run your hands across them, you can cut yourself. You got to be careful with that. Xuron really does make the best snips, but they're like $90 a piece. So, and these are more like 25. So, you know, compromises are made. These are 100 ohm resistors. We will do these next. Yes, Radio Shack iron when you were 7. Built the plastic P-bot kits. Yes. There was a little gosh, what do you want to call it? There were these little build it yourself. Gosh, little motorized cars that would take like a single AA battery and a tiny little motor, and you could put different gear sets in them to make them go faster or slower or whatever. I don't know if anybody remember those, but yeah. Are any other Brill computer kits available? That's a really good question. If Mr. Corbis of Reactive Micro is in the chat, he should be able to answer that a little bit better than me. Metcal, I'll have to check that out. Yes. As far as soldering irons, yeah. Weller's okay. You know, Weller's generally considered to be an okay soldering iron. Hakko is kind of considered to be the industry standard. I'm partial to my KSGER because it's insanely cheap. Somebody was saying that they had a Yahua with rattling bits. Yeah. There are some of those Chinese kits that actually do a really good job. They also come with the Yahua 939 that come with a built-in hot air rework station. So if you're doing SMD stuff, it's really helpful. If you watched my last stream and you saw the gigantic, effectively hair dryer I was using, then you'll understand and appreciate what it's like to have a proper hot air rework station with this smaller directable air gun on it. Is Vince Brill still making and selling any kits? See, that's a good question. I'm not sure if he's selling any of the kits on his website. Let's just take a look. Brill Computers, click. Click. Yeah. The Replica 1 is pretty much exclusively available from Reactive Micro. And Vince's website, for the most part, is saying all of his other products are out of stock. So I don't think he's really doing much anymore as far as that goes. The Replica ones are still available, and those are available from Henry. Yeah, there, Henry just answered that question. So what's next? Let's find some other little component to put on. Let's put the crystal on there. The crystal is a 5 megahertz crystal. That's a weird frequency, but that's fine. 5 megahertz flat. The crystal is a non-polarized part. It can go in any direction. That goes right there. We'll just use the weight of the board to hold it down nice and flush. I don't have to do any leg bending. That's another thing you want to do too when you're putting when you're assembling a board. Is you can when you're putting lots of components to the board, you can bend the legs over, and you may have seen me do that. That holds the items in the board, so when you flip the board over, they don't fall out. So that's in there. What's next? Let's do... here are a couple of 220 ohm resistors. let's put those in. Just got to find where they go. That's a 56. Here's a 220. One goes right here. There's the 220. Doobie doobie doo. I apologize if I seem like I'm rushing a little bit. I'm not intentionally doing that. I'm just really excited to get this done. It'll be the first time I've ever played with an Apple I-like computer or device, aside from GCM1, which is kind of a advanced Apple I when you think about it. And also, I would like to be able to get this built tonight and demo it on stream. So, okay, where does this other 220 go? Let's see. Again, it might be a spare. It might not be a spare. Nope, it goes up here. 220. There we are. Other things I use with my soldering station, I have a cheap little soldering holder. The company that makes it is called Avon. It's the 17530. It's a little $12 universal soldering iron holder. It also comes with a little cup with the brass cleaning thing, and it allows you to clean the tip of your iron by dunking it in the brass there. Of course, the little brass thingy is replaceable, so you can take that out and get rid of it. Henry making deals right there in the chat with folks. I'm all for that. No questions about that. What goes in here next? Capacitors. Do we want to do capacitors? Yes. So those are 10 nano, 50 volt. These are 100 nano. Now, we still got more resistors. Let's do more resistors. We've got a 10K, which if memory serves goes right up here. And we got a couple of 560. So let's put the 10K in next. Okay. So we're going to put the 10K in here, right like this. You can do it. You can do it, Joe. My eyes are failing me. I'm getting old. There we are. 10K. There we are. There's the 10K, and then we have the 560 to put in, which goes down here. Five, 6, 0. There we are. Yes, Henry's products are. Chris said Henry sells sells a quality product. This is absolutely true. Henry's stuff is excellent. His tech support is excellent. He's been doing a great service to the community for multiple years. So if you haven't checked out Henry's website, reactivemicro.com, and checked out some of his products, you need to go do that. I'm pretty sure a lot of us on the stream already know Henry, and we've already done that. But if you haven't, go look at his stuff. He has got super awesome products there. So I think I have all the resistors in, so let's go ahead and graduate to these small capacitors. These are going to be the next largest item. Now, we have two different types of capacitors here, lots of different capacitor locations, so we need to identify where things go. Now, I don't know exactly how to read like the capacitor values themselves by their point value here. I don't know how to do that. me plus math, we're frenemies. We rely on each other in order to get by, but we really hate each other and don't get along. So figuring out what that means is whatever. So I'm going to use a different brain technique and count them. So we have 2 of these, and we have 2 spots for the 0.01, and then a huge smattering of other C values, which are going to probably be all the 100. Now, I do know that 100 nanofarad capacitors are typically used for decoupling, so that stands to reason going as to what those things need to be. Now, I still have to be careful, however, because there are some capacitor locations here, like this one, which you can tell because it's got a large circle around it. That means it's going to be likely this larger capacitor, which looks to me to be simply a large decoupling or power supply capacitor for the whole board. And I don't see any other capacitors floating around, so that is going to be a good guess. So let's go ahead and proceed as if that is correct. And again, worst thing that could happen is it will blow up. But that's fine. I have a whole shelf of extra components over there, so if it does blow up, we'll just replace it. Now, these are the 10 nanos, which I'm going to presume are used for timing or some such. Yes, this one is on the 6821, so it's some sort of timing or decoupling capacitor. Again, I haven't read the instructions, so I'm not 100% certain, but it stands to reason. It's a little bit small for standard decoupling capacitor. And this one right here also connects to this pin, so it's like some sort of signal filter, maybe? High-frequency signal filter. That sort of noise on the line. Oops. So that one's in. And then the other one was up here. You really do have to say, or I really do have to say that Henry's quality is insane. I mean, how many folks ship you a product and they actually put an authenticity sticker on it with the year on it? I mean, come on. I just started selling stuff online, and the best I can do is like send it off with a smile and say, I hope it works. Actually, my products really do a good job. So those capacitors are in, so let's do these now. These are the 100 nanofarad decoupling capacitors. So let's talk about decoupling and what that is. So decoupling is very important. It's also called filter capacitors. They have multiple different names for what they are. But basically, when a digital circuit changes states, those are going to go flying all over the place. Let me do this a different way. When digital circuits change states from 1 to 0, 0 to 1, when those transistors in that IC change state, especially when they're clocking and all of that, that sudden state change, or really the period of time during the change between when it changes from a 0 or to a 1, it draws a little bump of extra current. This bump of extra current can cause the voltage rails it can cause the positive rail to drop and the negative rail to raise. And that can, if you have enough of those components all doing that simultaneously, you can actually pull your rail so far that it can cause items to switch incorrectly. It'll cause your circuits to not switch properly. And of course, we all know that that's a bad day. So what you do is you put small decoupling capacitors on your items. And what these do is when there's that sudden draw of electricity, these will provide that charge onto the power rail to prevent those little dips in power, and they increase the stability of the circuit quite a bit. Now, if you're doing a circuit with just a couple of chips, decoupling capacitor, really not terribly important. It becomes more important with the more chips you have and the higher frequency that they're switching at. I mean, if it's switching at a couple kilohertz and it's like 2 or 3 chips, like, who cares? It literally doesn't matter. But if you're running, like this thing is running at 5 megahertz, and you've got like 15 chips on it, like this thing does, yeah, that can be an issue. It also never hurts to design your board with the decoupling capacitors anyway. It never hurts. They're cheap, they're bountiful, and by doing a little bit of design in that from the beginning, you eliminate a lot of problems to start with. By just having those in there, you're removing a lot of the potential questions of during debugging. Is okay, so why is this chip doing this? Why is this not functioning correctly? I don't know. It doesn't make sense. Just throw decoupling capacitors at it from the beginning while you're just doing your design. One for every chip, typically, as close to the power rail as possible, to the positive power rail as possible, and it eliminates a lot of guesswork. You find your stuff just kind of works. Okay. Here I go humming again. It's a Joe's Computer Museum live stream thing for me to hum in the background. Doobie doobie doo. Okay. Sorry about the silence. I'm just focused. That doesn't want to stick. There you go. Okay, those are all good. Warranty tracking sticker, yes. Capacitors, yes. I'm just reading your chat messages. Yeah, Henry, I agree. Yeah, as far as both the sales and the shipping, it's weird because everybody's at home, right? So everybody's at home and they want something to do, but at the same time, because everybody's home, it is so hard to ship product, right? Like my store, my store right now is mostly just an automatic fulfillment house. It's like it's geek merch, but products ordered for there can take up to a week to get through processing, and then another week to just get shipped out, just because. Okay, so the capacitors are in. So now what's next? What's the next big thing that's going to stand up from the board? I think we want to put these switches in. Where are my switches? Here they are. Oh, 5mm push button switches. Super cute. Super adorable little things. Are these 5s or these 3s? That's a good question. Let's get out the magic measuring stick and we'll find out. Those are 6mm. And here is the thing. Now, I am really bad at determining which direction that these are supposed to go in. So, I might actually look at the instructions here. Actually, we can see, by the way it's built, it'll only go in a specific direction. Yes. These are bent a little bit, so we'll have to fix that. There we go. There's one. Who is it that says capacitator? There's another YouTuber. Is it Rodalco 2007? Is the guy who uses high voltage transformers to blow up televisions or whatever. He's got the coolest accent. He's from New Zealand or something like that. And he uses the term capacitator and transformator. Yeah, that's cool. Now these I'm going to tape in place because the pins aren't easy to fold over, and I need those to stay where they are to solder them in. Okay. Here's one. Here is two. That one's not quite enough solder. Let me hit that again. There we go. That's better. Okay, we got our clear and reset buttons. Make sure they still function. They do. All right. What's next? Let's start putting in some sockets. Yeah, sockets. I'll show you the trick for doing sockets. Now, sockets are kind of important to get to do the solder and adjust and solder, only because if you don't, they're like hanging out of the board at a weird direction and all of that stuff. So let's do these 40-pin sockets. Now, you want to note, of course, where's my pointy stick? You want to note the little notch here in the socket layout diagram, which corresponds to the notch right here in the socket itself. This is important so that you get your items installed in the correct orientation. Now, electrically, it doesn't really matter which direction you put this in, but you do want to follow the idea that pin 1 is this pin right here, and it is the lower left pin when the notch is to the left. So when this is this way, your pin 1 is here. Very, very important. In addition, you'll notice that pin 1 is a square pad, whereas the rest of these are oval pads. And why is that important? Again, for orientation. If you put your chip in backwards, it will blow up. And we don't want that. We don't want blowy uppy chips. We want chips that work. So this orientation is hard to see because there's a via right here, but I'm going to assume it follows the orientation of this. So we're going to do that same thing. This is 6821. That's the serial chip. Or is that a PIA? Is that a programmable programmable what's its uses? I don't remember what the 6821 does. Yeah, we got a bent pin. Hold on. A couple of them. There we go. Let's try again. There we go. Those are in. And I got a third one here somewhere. Where'd that third one go? There it is. Third 40-pin socket. And this is for the actual processor. The venerable, the powerful, the universal 6502. Oh, I broke the socket. Stand by. These dual wipe sockets can be a pain in the butt to install sometimes. They are very affordable, they are generally reliable, and the pins are super, super flimsy. I personally like to use, in my projects, machine turn pins or turned pins because you don't have all those issues. But they're hella expensive, so, you know. So we very carefully came out of the socket again, stand by. There we go. We very carefully turn this guy over. There we are. And we're going to do the corner pin trick. So we'll start with pin 1 on each, which is the square pin. Press down on the board, get pin 1 in there. Pin 1 is in. Flip it over. Actually, I should do pin 1 on all of them so it doesn't fall out while I'm flipping it over. Not doing it correctly. There we go. Pressure on the... I'm putting pressure with my middle finger here to make sure that it comes up through the board correctly. Get that in there, hold the pressure till it solidifies, let go. Same one here. Pressure, hold it down, add solder, wait till it solidifies, let go. Now those should be in there pretty well. We can double check. They are in there pretty well. Now this one's a little loose, you can see, so when we put this in, again, we need to make sure we do the press down trick to keep it in there. So now that they're in there really well, you want to press down on it and do the opposing corner. That makes sure that it gets in there aligned super nice. I apologize if I haven't been paying attention to chat. I love doing these projects so much. I just kind of get on my own little thing and I get rolling. I forget people are even there. I'll read chat in just a moment. There's that one. Wait for it to solidify, let go. Hold down, add solder. Wait for it to solidify. Technically it's freezing. It is a liquid and it turns to a solid, so it's freezing. Let go, double check. Yep, those are all nice and even and perfectly aligned to the board. What's everybody said? Bent pin on that socket? Yep. Apple ones didn't have cases. Blasphemy. Who's saying that from before? Let's go all the way back. Peter Van Horn, what's up? Everything! My brother does doobie-doobie-doo when concentrating do. Yes, 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 yes. Compared to Bling Bong from Mission Hill. I haven't seen that cartoon in ages. Does he also say orientated instead of oriented? That's a good question. I don't know. Is there a case available for the kit? No, but if you have a 3D printer like I do, you can design one. Yes, any random socket direction will do, just as long as you know what your pin 1 orientation is. Check the pins to make sure they were all straight. Yes, I did. Would you build a wooden case or put it in a briefcase? Yes, that would be fun, wouldn't it? Yes, you should solder the pins diagonally across. I just did that. Yes, yes, Chris, preferring machine pin sockets, but if you aren't used to them, it's easy to bend IC pins. Yes, so that's the other thing. These dual wipe sockets, while the pins are kind of when you bend a dual wipe socket pin, it's easy to bend back. If you bend one of the machine pin sockets, it snaps right off, and then you've just wasted $5 on a machine pin socket. So that is something to keep in mind. Okay, so let's get this finished up here. This one pin does not want to go all the way through. This is the one that I got poked out. This is my pokey tool. If you guys don't know what this is very commonly referred to as a spudger or a black nylon stick. It's frequently used when working on cathode ray tubes because it is non-conductive, super long, and it's got little end on it here where you can use to turn potentiometers and stuff. I have a whole bunch of these. I keep them around because they're good for pointing, they're good for spudging, they're good for popping chips out of sockets and things like that. Okay, so let's solder the rest of these pins. Marathon solder in 3, 2, 1, go. It's a little dry. There we go. Now, some folks think that you should do these across from each other to let the plastic cool. You can. I've never had a problem just doing them in a line. Whatever fits your fancy. Just remember you don't want to stick on the pad and the pin too long, again, because of that plastic. Plastic is heat resistive, but it is not, it's not, you know, completely impervious to heat. You do want to dwell on the pin for a little bit to make sure that the pin itself comes up to heat. As you see, I'm putting the soldering iron on the pin and pad first. I'm contacting the pad, sliding it into the pin, then adding the solder, letting the solder flow in, then letting go. And of course, this chisel tip does a really good job of helping me do that. I can put it at the side like this. You know, I'm orienting it like that to get good contact and a good spot for me to touch the solder to, for it to just melt and go right in. Just sucks right in, sticks to the metal. I have to say too, this board is super high quality. It has the gold-plated through holes and pins and all of that stuff. Some of that is aesthetic to match the original Apple aesthetic for their pins and sockets and stuff, but some of that also is too for quality. The gold contacts just tend to last longer because it's gold. Gold is an insanely unreactive metal. If you know your chemistry, it takes the mixture of two very special and specific acids just to dissolve it. A piece of gold left out in the weather will stay looking like gold, completely untarnished, literally forever. And the only time you'll see gold actually tarnish is when it's alloyed with something. So if you've got something other than 24 karat gold, like if you got a low carat, like a 14 karat, it can tarnish a little bit. But what that is that's the copper in the alloy. And typically it will tarnish green. Greeny bluey, the way copper tarnishes. And that is your Cody's Lab gold education of the day. Doobie doobie doo. There we are, that one's done. Now to do this one. Yeah, not heat proof, heat resistant, yes. Yes, gold does not oxidize. This is correct. Gold is not anything. Gold is it's almost like a noble element in a way. Like, I mean, you can get it to react with things, you know, if you know your chemistry correctly, but just out in the air, gold just sits there. It does not oxidize. It does not react with anything. You have to go to very careful and specific pains to get it to react with anything. This is one of the reasons why gold is considered such a valuable commodity. This pin looks weird. Stand by. Now, looks like it screwed up that pin. Now, if it's screwed up, it's screwed up. I'm going to check that because I think Henry was telling me in the chat, and I didn't pay attention, that one of those pins was bent over. So, however, it was touching the pad on the other side. So if it's touching the pad and the solder made connection, it's probably fine. It's this pin here. Yes, it makes connection. I'm not worried about it. So basically, the pin was folded over and did not go through the hole. So effectively, that pin turned into a surface mount lead and not an actual through-hole pin. But because there's pads on both sides, I flooded it with solder and it made connection anyway. So we will just assume that it is okay. If it's not, we'll find out, won't we? That's part of the fun of soldering. Part of the fun of putting these kits together is making little mistakes and finding your mistakes and realizing, oh, oops. Being able to go back and fix it later. Because if it works for the first time, that's almost like, well, where's the fun? I could talk about the search for changing lead into gold and the symbolic meaning of the search, but I would rather watch Joe work. Well, thank you. I am glad I am more interesting than alchemy. which is a lie, of course. I'm not that interesting, but okay. Just some weird dude in the Midwest in super hot Ohio playing around in his basement and hoping other people enjoy it. Are. So those are all in. Cool. Those are the 40-pin sockets, which are the ones that take the longest because 40 pins! So let's do some more sockets. Let's do these. These look like 32-pin sockets. A couple of those for these. And what these are, these will be the ROM chip, which contains the pre-programmed program, the WAS monitor and whatever might be in there. And then the 62256, that is an 8 kilobyte memory chip. 8 or 16? 256 divided by 8, whatever that ends up being. Kudos to the first person who can do the math and put it in the comments. There we are. Again, we press down, do pin 1, wait for it to solidify, press down, do pin 32, same deal. Repeat. And repeat. Okay. Math, I'm out of here. Yeah, 32K. Okay. Yeah, Heath kit with point-to-point wiring. Oh man, now that is vintage stuff. Good old point-to-point wiring, man. There's a guy I watch on YouTube, Shango066. Grumpy old Gus, but the guy knows his stuff when it comes to old tube TVs. I like to watch him work on the old tube TVs, where everything is just absolutely analog. Where they figured out the, your resonant frequency for your vertical and horizontal deflection through, capacitors and tuned coils. Just craziness. He likes to find. He likes to go to old mines out in Nevada and California, find old tube TVs with permission of the property owner, of course, and finds, where they've been out there for like 40, 50 years, and takes them, plugs them in, and makes them work. It's crazy. Okay, that one's done. One more to go. Of course, point-to-point wiring. It's kind of like wire wrap. It depends on how it's done. But point-to-point is really just, you just throwing stuff. Is before the concept of printed circuit boards and before the technology was really there to put metal traces on boards. But that's some crazy stuff. It's like, it's quite specific too, because you almost have to design three-dimensionally, because you have to be careful not to cross your wires in the wrong spots and have two things with dramatically different voltages or dramatically different parts of the circuit touching each other, because all these bare circuit leads are just crossing over each other. It's crazy. Wire wrap's a little bit safer and came in later, but really you didn't see that a lot in the kits so much. Wire wrap was more popular in electronics kits than it was analog stuff. So those sockets are in there, and they're in the correct orientation, and they look good. Yes. So let's do these 2 sockets next. That's going to be these guys. These are the socket for the 74LS00, or actually for the 138, and for the ASCII keyboard. I actually happen to know what a 138 is. It's a 3-to-1, or an 8-to-1 multiplexer, or signal selector, 3-to-1, 3-to-8, 3-to-8. It's a 3-to-8. So basically, it takes a 3-bit value and then turns on, depending on the value of 0 to 8 of those 3 bits, it turns on a signal of 0 through 7 or 1 through 8 on the output pins. It's typically used for decoding logic. It's typically used or for I/O selection. You're going to do it. There we go. Okay. Yes. Professional wire wrap with a torque gun, absolutely. If anybody out there has one, I'm looking for a wire wrap gun that was used on telco frames by AT&T technicians back in the 60s and 70s. Has a part number that starts with KS. So if you got one of those and you're looking to part with it, I would love to talk to you. Is this going to do the thing, or what? You going to melt? You gonna do it? Are you going to do it? There we go. Of course, you can use flux on this as well if you like. You can add your own flux. What the flux does is it helps clean the pads, and it changes the chemistry of the metal slightly so that it liquefies and connects better with the other metals. Flux isn't quite as necessary, or more specifically, pre-cleaning of your pads isn't as necessary when you're dealing with gold pads, again, because they don't oxidize. They don't really get anything on it. But if you get your fingers on them, you smudge them, you can cause them to where they don't want to, you get the oil on it, and it doesn't want to, how can I put it? It doesn't want to bond, so then you can get something like a flux pen like this. This isn't really used for reflow or anything. This is basically for pad cleaning, and you just clean the pads like that, gets all the goop off of it. It's kind of a solvent, and does the job. Okay, what's next? Let's do this one since we have that one out. This is for the keyboard, which we will not be using. In theory, you can plug an Apple II keyboard into this, I think, and use it old school, but we're not going to be doing that. I'm going to be using a PS2 keyboard because I happen to have it. Yep, that's in there good. Well, that's people talking. Yes, Henry, my concept is to make kits not only fun, but as simple as possible for newbies too. Absolutely. Yeah. I don't know how else. I don't think Henry basically said it the best. Henry's stuff just tends to work. Plug it in, turn it on, does the thing. If it doesn't do the thing, you didn't follow the instructions. Yes, Kurt, they call the 138 3T demultiplexer. Yeah, I wouldn't really call it a demultiplexer. That's really not the right term for it. Because it's not like you're taking multiple signals and separating them into two outputs or anything like that. You're taking a binary value and converting it into a select signal based on the binary value. So it's really it's a decoder. Okay, what's next? More sockets. I have one more socket to do here. I've got two more sockets to do. I take that back. Just got to find it. Here it is. This is for the 74LS00, which is a quad NAND chip. The NAND chip being one of the universal logic gates. You can use a NAND chip to make literally any Boolean logic that you like. The other one you can use to make any Boolean logic you like is a NOR gate. NANDs and NORs are both universal. For example, you can tie two NANDs together to make a, hold on, you can tie two NANDs together to make an inverter. So if you're doing a design and you think you need an inverter, look around for spare NAND gates. You just tie the two inputs of the NAND gate together to the single input that you want, and your output will be inverted. That way you don't have to add a chip. Make sure that's aligned well. It is. It looks good to me. Okay. I saw somebody say something about the size of the board. It is about 1/8 of the size of a real Apple I. Yes. And the magic behind all of that, of course, as we know from both the Apple I and the Apple II. I'll go into that briefly. Basically, I like to quote Quinn Dunkey on this one. The Apple I was a sophisticated television video generator with a computer attached. And the Apple I was basically the same way. A lot of that logic was just timing and video generation. And glue logic to make all the bits and pieces talk to each other. So, in this case, they've done, Vince has done a really good job of tying all that in with this propeller chip. Of course, the propeller itself is a magical chip that has a built-in NTSC output in it. It creates NTSC video. It just comes out the side. So, you know, you don't have to have like all of this board out here generating NTSC. You just you program the propeller correctly, and it'll do what you want it to do. And of course, it's doing the majority of the glue logic, the decoding, and all of that other stuff too. It just does all of that. It's kind of a special purpose. Not really a special purpose. It's like the propeller chip is a weird chip. Whereas like an AVR or a PIC, most AVR microcontrollers and PIC microcontrollers are pretty generic. The propeller's got a lot of really cool built-in functions. It's got these concepts called cogs or something like that. Like it can run 8 simultaneous processes or something like that. It's really weird. It's really cool, but weird. But that makes it powerful. Okay, that socket's in. What's that chip? What is that chip? That is a 24LC256. I'm willing to bet that that is bootstrap code for that, for the propeller, if I had to guess. So what else goes in here? Let's look at some of the bigger stuff. We've got the big capacitor that's got to go in, so let's do that. Let's put the, no, I want to put the transistor in first. This 2N4401. Is it a transistor or a watchdog circuit? I don't know. somebody in there knows. It's in the TO38 or TO92 package or whatever it's called. Looks like a transistor to me. That will go in the general vicinity of something right here. It's labeled Q1, so I'm going to guess that that is actually a transistor. Part of the reset circuit. It's right near a it's right near a resistor and a capacitor, so that would be my guess. Max, I'm from Brazil, Joe, and the first Apple II Plus I saw was an Apple, was a Unitron. Oh, that is awesome. Yeah, Apple, you know, they tried to be in certain markets and they couldn't, so there were clones and or authorized clones and stuff in these different markets, and which for most of them they were literally direct circuit board clones, so they were pretty universal. TO92, yes, thank you, Chris. SPIE Prom MV RAM, yep. Yes, the Propeller has 8 32-bit cores. That's just nuts. It is a crazy, crazy chip. Super powerful. I mean, it's the Propeller itself is more powerful than the entirety of the rest of this board. It's really just, it's doing all the magic glue and kind of just does it in the background to make it function the way you expect it to. So what's next? What else do we want to put in here? Let's put in the LED. Let's put in the big bright maker. Also called an indicator LED. Nice big fat 5mm LED. Wow, those legs on that LED are insane. Long leg here is our positive, and we'll want to check that right here. And we see our positive is on the left side, as is the typical convention. Long leg on the left, so that goes there. There we are. Doobie doobie doo. How long has the stream been going on for? We've been going for about an hour and 15 minutes. Hopefully we'll be done pretty soon with the build so we can actually play around with it. I try to keep my streams to about 2 hours. That's about the attention span of your average nerd. Okay, can you be unstuck, please? There we go. Now those are really, really nice leads. So I'm going to hold on to those because those are good for projects. So the LED is in. Let's do the large capacitor next. Where is it? It's not that. I know it's here somewhere. Oh, I know it's here. Here it is. 10 microfarad, 25 volts. That's right at the input power, so that's going to be basically a power supply capacitor. Again, long lead. Goes in the positive side. And also these guys, the negative side on a polarized electrolytic capacitor, which is the short side, also has the little minus stripe on it to tell you the negative side. Okay. I'm going to do one side. Check alignment. The alignment on it is pretty good. And do the other side. There is the electrolytic. Cool beans. What's next? Let's start putting in some of these big things. So let's try the USB interface, which is also used for power. Special circuit board that does magic things for us. It doesn't really want to go in. It's being belligerent. are. That's in. Of course, this effectively acts as a serial interface and a power interface, so that you could use this with a terminal emulator, for example. It's basically a USB to serial adapter, but built onto the board here, so you can just plug it in. You don't have to have your own separate 9-pin adapter dongle thingy. Get the one corner in, make sure it looks good. It does. Do the other corner. Make sure it looks good. It does. Now, this doesn't really show you the orientation of this on the board, the instructions to say it, but it's pretty obvious the USB comes out this side, because if it came out this side, it wouldn't work right. That makes obvious. Okay. Get this in here. USB adaptery thingy. And once. Yep, okay, just making sure I'm still on frame there. That one's a little dry. A little bit. Okay. Now I'm not going to cut these, I'm going to leave those in there. Leave those hanging out for now. What's next? Let's do the on-off switch. Where is that? Where are you, buddy? Here is the on-off switch. Since we're in the neighborhood, might as well do this one. As you can see, I'm also putting a piece of foam in here to give me something to push against to get that down in there. Doobie doobie doo. Oh, there I go at it again. Of course, these ground planes can be pretty hard to get soldered, because a ground plane is a gigantic heat sink and it sucks all your energy out of your all your heat energy out of your iron. So you have to have a good iron sometimes to get those going. Helpful. Little power switch. There we are. Power switch is in. Cool beans. Let's get the video socket. Big guy, yeah. That is just it. That's wobbly. Doesn't really want to stay in there well, does it? Alright. This one's going to be fun. This is going to be buttloads of solder. Lots. Welcome back as Reactive Micro. Cool. Yes, back to full time. I'm glad to see Henry's back to being able to do things full time. So of course these the video connections takes enormous amounts of solder because these holes are huge. But that's okay. I have lots. There we are. Video socket connected. Looks good to me. Now let's do the Ps2 Jack. This is our keyboard jack. Of course, the propeller is handling that as well. It's handling the keyboard input from the PS2, doing all of the IBM keyboard format decoding and all of that stuff. Now this can be a little tricky because it's got this kind of spline connector. And you have to use a fairly significant amount of force to get that to go through. But you got to be careful that you have these pins here lined up, because if you go to force that and these pins aren't lined up, you'll bend the pin over and you'll have a bad day. My pins are lined up, so we just press hard, it goes through, and there we are. And now it's solder time. Now these things, of course, that have the nice press fit connectors, they just hold it in there, so you don't have to use foam or do the multi-point soldering or anything like that. You just kind of do it. You can do it. There we go. And now the big connections and buttloads of solder. One. Two. And three. Ps2 connections in. Push, it's hard. Yes, it is. It just, yes. It took a lot of effort to get in there, and you just got to be careful with the, again, like I was saying, you have to be careful that your signal pins, the smaller pins, are aligned before you press, because if you don't, you're going to fold it over, and, you know, most pins like that, if you fold it over at a right angle, you try to fold it back, snaps right off, you lose your part. It's a big pain in the butt. Doobie doobie doo. Yeah. People are commenting on the different like point-to-point solders you can use. Yeah, when you're doing the point-to-point, you kind of want to use thicker solder, like this stuff. You know, this generic stuff. This is kind of what's the? This is 050, and this is 010. So you can tell, you can see the thickness difference in those two. When you're doing point-to-point, sometimes it helps to have one of those solder guns as well, where it's like 2 points that come together like that, because it has a nice fine point, but because it has those really long prongs and it's passing electricity through it, it has really high thermal capacity, so you can sink a lot of heat and not lose a lot of heat out of your solder. Yeah, the Hakos, the 936. Yeah, the 936 can dump as much heat pretty much as you want, unless you're soldering something thick as your fist. You'll be fine. So what's next? Got a couple of these things, these little pin headers, and these are for jumpers. Now, I'm going to assume that those go here, because this is an enable option, and here, which allows you to select the, it's the ROM select, allows you to select your program in the program ROM. So I'm going to guess those are those. And not these other pins here, which I think are like test points, because those are not labeled. So we take those and we put a little fuzz over them, flip them over, and solder them. One side, one side, take it out, take the foam off, make sure it's aligned. That's pretty good. Yep, good enough. And then we do the other pin. That's hot. Yeah, don't put your hand on that. Ground planes have a lot of thermal mass, which I just found out the hard way. Okay, and then we have our little jumper shunts here. And let's start with integer basic, because that seems a little more authentic to the Apple I to me. And then this is ASCII enable, which we're not going to be using. So I will set that to off as well. Now we've got this guy to put in. Hi, can someone tell me a good solder station to get? Yes, the standard Hacko solder station is really good. The Yahoo 936, I think it's called, is good as well. Because it has not only the temperature control and the soldering pen with it, but it also has a built-in rework station that works really well. I use a little cheap KSGER T12 soldering station. I'll put the name in there. Yes, the FX888D, that's the Hacko. Basically the industry standard. You can't go wrong with that. It will give you years and years and years of excellent service. I also have a little thing I'm doing on kit.co right there with a list of the different tools that I use. If you buy something through there, it doesn't cost you anything more to buy it through there, but then I get a little bit of something that helps me keep the museum stock. So if you want to click on that link and buy stuff through there, helps me out. You don't have to, no requirement there. So let's go ahead and put the what is this thing? Card edge connector. There you go. Put the card edge connector in there, and of course this is not this isn't polarized in any way. It doesn't matter. So we just kind of put it in there. Yes, the KSGER, the one that I have actually came with the tips as well. So you want to look for that one on Amazon. If you go to my kit.co link, it goes straight to it. Or if you're looking on Amazon, look for the one that's $79.99. It comes with the unit, the pencil, and it also comes with like 4 different tips. So. Here is that pin. That needs more solder. That's better. What is this thing? Are you asking what I'm soldering? This is the Briel Computers Replica 1 Plus. It is an Apple I replica that is exclusively sold by Henry Corbis over at reactivemicro.com. Henry is in the chat, so if you have any questions about the specific functionality, he should be able to answer your questions. More solder. There we go. I'm not too happy with the alignment of that, so what you do with that is you put the pressure on the direction you want to change the alignment. I want to change it in this direction, then you heat the solder. So, let's solidify, and then now it's realigned. Perfect. So now we can add solder to all the joints. Something I forgot to mention before, maybe I didn't mention it, as you can see I'm dwelling on the solder point after retracting the solder, just for a little half second. That allows the solder to flow into all of the little nooks and crannies and get a good connection, and it also allows everything to heat up to the same temperature. the solder bonds better when the metal it's bonding to is the same temperature as it. Here's a cool trick too. You see this little piece of solder that fell off right here? It's easy to just suck that up. You just stick your iron on it. It'll suck right into the iron. Solder gone. Right now, I'm just thinking to myself that having a fume extraction hood is very, or not a fume extraction. Wow, what is this? A chemistry lab? A fume extraction system, a little, little fan with the filter in it would be helpful. But right now, because my air handling unit is on, I have a really good airflow around the shop, and these fumes are just basically blowing right past me, and not even really getting in my way. So. No problems. Everybody's talking about their awesome reactive micro products. Yes, yes, yes. That's why I was happy to put this kit together and give a little extra love and support there to Henry and his products. This isn't, just to be clear, this isn't sponsored in any way or anything like that. I just bought this kit from Henry. He's not giving me anything for free. I just like to support the retro community, especially on products that I really, really like, especially from vendors I've purchased from before, because the more knowledge, the merrier about what's out there, what's available to keep your old retro computers working, or in this case, for building a new retro computer kit, having something fun to play with on the weekend. Doobie-doobie-doo. Another thing to note, of course, I mentioned the kind of solder. I'm using Kester rosin-based solder. Again, on my kit.co link there, if you go to that, you'll see the exact solder I'm using. You want to make sure that when you're doing these projects, you want to be bad to the environment, unfortunately, and use lead-based solder, because lead-based solder is the best for hobbyist work. It melts well, it fuses well, and it just works. It works properly every single time. The newer environmentally friendly silver-based solders do not melt well. They don't stick to things well. You have to make sure your surfaces are super clean. You have to use lots of flux. You have to be super careful, because if you're not, it doesn't bond. So I think we have all of the passive components in there, so let's get the active components installed. So here's the 74LS00 again, which is a quad NAND gate. Now I should probably be wearing my wrist strap for this, although the 74LS series aren't terribly static sensitive. The other products, like the 6502, are, so we want to make sure that we are taking care of that. I'm going to use my little chip lead straightener to straighten the leads on that so that it goes into the sockets really nice. That goes in here, and of course we want to match the notch here with the notch on the top of the board. That goes that way. I will also show you the trick to putting chips in if you don't have one of the straighteners. It's really easy. It's called rolling the chip. You just put your chip on a surface, hopefully a surface like this that is static neutral. This is a static mat that is actually connected to ground to keep static off of it. You put it on the surface and you roll the chip very, very carefully to straighten the pins out. Just like that. Now the pins are straight, and now it'll go in the socket. Maybe. It'll go in the socket. It'll go in the socket. Let's use the pin straightener for that. Let's try that again. This is the 74LS138, the 8 to 3 decoder. That goes right in there. Now let's do the 62256, which is a memory chip. That's going to be this one here. Yep. There is our memory chip. Pin straightener. Straighten the pins. In the socket. Now remember, this is the chip with the weird pin. So if we find we're having weird problems, it's probably that. Now let's open this bag of goodies up. Now here is probably the most expensive chip in this entire thing, this Parallax Propeller chip. Yep, that went in correctly. We've got our 27C128 chip, which is our ROM chip. This is a EEPROM, erasable programmable read-only memory. It has a little window here, and you use ultraviolet to flash it to all ones, or basically to zero it out, so you can reprogram it. So that's in there. We got our tiny little serial memory chip here, which goes in there. Oh, this guy's grumpy. This guy's super grumpy. He's got bit pens all over the place. Super bent. That guy goes right here in the tiny little socket. Now we're going to put in the 6821. The serial, or I don't know, what is a 6821? 6821 is either a serial chip or it's a parallel or programmable interface chip of some sort. I don't remember specifically. With the number of pins on it, it looks like it's similar. It's like a VIA. It's similar to a 6520, 6522. Oops, I almost screwed that up. Do you see that? It's in backwards. Flip that around. Yes, goes this direction. Here we are. That would have been a bad day if I had that in backwards. And finally, the last chip, the most important chip. The wonderful, the venerable, the reliable 6502, my favorite chip in the world. This chip is so much my favorite that those of you who know me know that my license plate is 6502. (6502) in place. The build is complete. Now, let's hook it up and see if it works. To power it up and make it work, all we need is a USB cord to go in there, and we need video to come off of the video port and a Ps2 keyboard to run the keyboard. So let's find out what happens when we do that. So I'm going to switch cameras real quick. to save you shaky cam, because I'm going to move the bench cam over to the side here to point it at the monitor so we can see what goes on. So let's turn the monitor on. Move my camera over. Stand by while we do this. Doobie doobie doo. There we are. Cool beans. That's about right. Doesn't really want to line up very well, but we'll work on it. Alrighty. I know I'm futzing with things and being silly. I just want it to look good for you guys. There we go. We can switch back to the stream, and now you can see the screeny screen. So let's power in the USB connection. I need a different connector. This one will work, I think. It's too short. I have the wrong cables. Stand by. Should give it a little more length. There we go. There we are. I have the right cables in now. It's the Living Computer Museum permanently closed. Yeah, that is so sad. It's one of those places I always wanted to go to, but, you know, I never had the chance, just generally speaking, not like, oh, I should go, but decided not to. It's like I never really had the opportunity to get out there. And now that it's closed, it's like, oh. Okay, so let's get the power plugged in. And get the video plugged in. And get this ancient, gigantic keyboard plugged in. Yes, I have an old PS2 keyboard, because of course I keep old things around like that. All right, power switch. Let's find out what happens. Power is on. I have no video signal. All right, so let's check our chips. Let's hit the reset button and see if it needs that. I'm going to check my chips to make sure my chips aren't overheating. They are not. Everything seems to be okay. Okay, well, we're going to turn it off. We're going to double check our chip seats to make sure they're seated. Make sure they are in the correct direction. They are. And I know that I have all my components in. And I know that I'm not missing anything. Try that again. It's also possible that my video connector to my monitor is screwed up. Interesting indeed. So while I'm playing around with this, how's the switch on the USB board set? Well, it's set to the right. Let's set it to the left. That didn't do anything either. Interesting. So now we get out the instructions and I double check. Check continuity between video pins on the other side of the PCB. Make sure there's no short. Yes. I'm just double checking. Doesn't say anything about that needing to be reversed. Let's double check this, make sure I don't have a continuity problem between those two pins. I do not. We're going to, for the time being, switch you back down to board level so you can watch me diagnose it. So, that looks to be okay. You see, it wouldn't really be interesting if there wasn't a failure, right? Make sure I do not have a short between the video pins. No short between the pins, so that's fine. Okay, so let's flip it back over. I'm going to turn on my oscilloscope, and we're going to see if I'm actually getting any video out of the video pin. The oscilloscope that I am using nope. Somebody said unplug the keyboard. That didn't help. No crisis, only cry as of right now. Yep, you are correct. I has a sad. So let's check and see if we have any video actually coming out of it. It is on. This is grounded. It is outputting a video signal. I can see it very, very clearly on the oscilloscope. It is oscillating. So I have a feeling it's actually my video cable. So stand by while I swap this stupid thing out. I was having problems with this cable earlier. Oh, camera's falling over. Oh no! Ha 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 ha! There we are. Yep. So we're going to plug our keyboard in. Switch you back over here. Turn it on. Ha-ha! Reset. Interesting. We are getting weird noise on the input. Now, if I remember in the instructions, or on the wiki, there was something about that where I have to add a resistor or something somewhere, because in some weird instances you get noise on the screen like this. And it's basically because of dirty power. And I can tell you right now, I have the wackiest power in this entire neighborhood. I'm just playing around with the reset button right now. I'm typing in numbers, and you can see the numbers are making it in between all of the noise there. Interesting. Never even seen noise like that, though. That's nuts. I'm going to unplug it. It's also possible, now remember, one of these pins on the memory was wonky. It didn't solder through correctly, so there could be noise getting on the board from that. So I'm pressing down to see if that'll make contact and fix that. That doesn't seem to have anything to do with it. The keyboard itself is unplugged, so that doesn't have anything to do with it. Right now I'm just flexing the board, playing around, flexing pins and things. Yeah, I think I got a bad solder joint somewhere is what the problem is. Because I just flexed the crud out of the board and suddenly it's working. That's pretty typical. Reset. Mm-hmm. Yep. So it looks like I need to do a little bit of reflow. That's okay. I think I know where the problem is, though. I think the problem is on the propeller, the pins for the propeller chip itself. When I was playing around with bending it there, that was having an effect on it. So we will do that. Stand by while I switcheroo you around so you can see what I'm doing. So I'm just going to reflow all of the pins here on the propeller. Yep, see, this pin on the propeller didn't go through all the way, remember? So it's effectively acting as a surface mount pin on the other side. So I'm just going to add a buttload of solder to it, hope it melts through and connects. Because if it doesn't, I'm going to have to suck this socket out and replace the socket. It's okay, I got extras, but add a whole bunch of solder to that. Hopefully that goes through the other side of the board and makes contact with that pin. That's the theory, anyway. All right, let's try it again. I also believe that this socket just broke. Nope, still getting wackiness on the screen here. See that? I just pressed down on the parallel or the propeller chip, and a lot of it stopped. I've let off of it, and now it's making noise again. Yep, that is just a bad socket. So I'll have to replace that socket to fix that, but I'm not going to worry about that at this point because we're starting to come up on 2 hours time, aren't we? So I'm just going to let you guys sit back and watch that for a minute. So that's a good demonstration of what not to do when putting your parts in. You want to make sure you don't bend pins, because bend pins equals bad day. I was hoping to have some time to properly demo that, but it's not going to be the case. However, I will show how can I put it? I will show you I'll come back to it in a follow-up video. I'll just put it that way. Yeah. Pressing down on that socket, and the problem tends to go away. Yep. Or just suck out the one bent pin, pull the pin out, and use. You know, let's try that. That is a quick and dirty test. Wow. Yeah. This socket right here just came out of that. See that? See how loose that is? No, you can't, because I'm not in the frame. This thing just snapped off of there, just from pulling that out. Interesting. Very, very flimsy, that. Now, of course, that can't really be faulted on Henry or Vince Briel. That's whoever manufactured this board itself, which is just an add-in board. But that makes me kind of grumpy. I'm going to have to do some surface mount solder fix to that, add some glue to it so that that stays in place. But yeah, the idea here is to try to suck out this one pin. I'm turning on my my sucker tool here, so I can pull that pin out. You can get under there. You can do it. You can do it. I want to be grounded here. Now. Models are touchy for end users. Yeah, I can send a new one. Henry, I will see if I can fix it myself. If I can fix that module, don't worry about it. But if I have a problem with it, I'll let you know. So we need to pull that pin out, which is this one right there. Just going to leave that pointed at it so I know which one. Got our magic solder sucky tool. This is the Hako FR301 vacuum desoldering pump. Okay. So that is going to be 1, 2, 3, 4, 5, fifth pin in. Can't really see what I'm doing, I apologize. 1, 2, 3, 4, 5. It's this one right here. Can I get that out? Doesn't really want to come out, does it? Might not have all the solder released. It's in there pretty good. Just trying to get behind it so I can fold it out, get a hold of it. Reflow the solder and pull out, in theory. Everything's theoretical until you see it happening. Here we go. I got a hold of it now. Okay. Get a hold of it with this. Not really. This is gonna be, as we call, it's gonna be footery. I apologize again for the view because the camera is not set up for this. Yeah, that does not want to come out of there. Looks like I'm gonna have to replace the entire socket. I can't get that pin out. Just doesn't want to come out. Welcome to the 70s homebrew computer experience. Run a jumper wire. Yeah, I can do that too, but now I've destroyed the socket. The pin, I mean, there's no pin there. Try it one more time. I don't give up too easily. just doesn't want to come out of there. It just don't want to. Can't get a hold of it with anything that's got a good grip on it. Ah, there we go. I got it. It's out of there now. All right, let's clear that solder out again. Best way to do that is to add more solder. I know that sounds weird, but that's how this works. Add more solder so that this can get a good bite on it. There we are. That's cleared out. Now I need another pin. Here's what this is for. Do I have spare pins? Ha! Yes. Yes, I do. Now we carefully put the pin in. This time making sure it goes all the way through and actually comes out the hole on the other side. That would be helpful. Oh my gosh, there's actually a pin there to solder to. Okay, let's do that. Got goop on that. There we are. Cool. So that's there. Okay, now I've got to fix this thing. I should be able to just heat those pins up. Is this a fine enough point to get in here? That is a good question. About to find out, aren't we? Got a little bit of a solder bridge. Got to clear that. I'm going to use a little bit of flux. Flux is always best for SMT stuff, surface to mount technology. Just a little bit of flux in there. Okay. Yep, I see your note there about adding the capacitor. Yes. I think I still have a solder bridge in there. Where be my solder? Here it is. The iron's super clean. Add a little to the iron. It's really not the way you're supposed to do it, but hopefully that will fix my problem. Ah, there we go. I got it cleared. Sweet. Now we can resolder the corner. And resolder the corner. There we are. Double check with magnifying glass. Apologize if my head is in the shot. Looks good to me. No longer wibble wobbles. Hey look, I did surface mount. Yay me. I'm going to put my flux to the side. Now we'll put this back in. Oh yeah, it is synchronous. Okay. I was just checking the video. Sometimes the video desyncs. Chip is in. Let's unplug this. Plug this in. Turn the monitor on. Plug the monitor in. Plug the keyboard in. Very, very, very carefully plug the USB in. I'm not sure that worked. Yeah, nope, it didn't. Yep, it just snapped right off. Yep, Henry, can you send me another one of those things? Yeah, that, man. Not happy with that design. That thing just... Well, we know it works, so that's an upside. Okay. Well, there we have it. That is our assembled kit. The Replica 1 kit by Vince Briel, distributed by Reactive Micro. Clean up my bench a little bit here while we're in post-assembly chat here. Can you force feed 5 volts onto the board? Probably. You know what? That's a good idea. Let's see if I can find a couple of points to do that. First off, let's remove this if I can. I'm just going to get that socket right off there because it's going to short things out and be a problem. Oh, heck yeah. Wow, it pulled the traces right off the board. There's nothing for there for it to solder to. Look at that. Traces gone. Nice. So the question is there 5 volts I can connect to? Well, I happen to know where, or I can look up where 5 volts and ground are for some of these other chips. But I'm worried that this also does 3.3 volt conversion. It looks like it might. So we have to be careful with that. Bottom of the board has ground and 5 volt pins, yes. I just have to find out which ones they are. There's also the power switch that'll help tell us that. Henry, do you know exactly, by the video connector is also 5 volt connection, okay. Ah, yes, I see them right there. Right here. Does it need the 3 volt? Not sure 3 volt is actually used. Good. So I'm just going to solder a couple wires in there to see if we can make it work. How's that sound? Because you guys really want to see this work, so let's make that happen. Stand by. What wire do I want to use? I want to use this wire. I'm going to be out of frame for a moment. Wires. All right, so basically I'm just going to take these and wire them up into this voltage right here. I want that to be on 18. These are my favorite wire strippers. I'm kind of close on the camera right now. Simple South wire notch cut wire strippers. I have tons of these things. I keep in my mobile kit and all of that stuff. Okay. Ground. 5 volts. Of course it fell out, because of course it did. That's fine. Volts. That's ground actually, but that's fine. And 5 volts. Again, I apologize if you can't see what I'm doing. I have the camera in a weird spot. All right. I want to get that in there a little bit better. Okay. Cut off the leads. Okay. Let's see what happens now. That's plugged in. Keyboard. If you see me smiling, I'm just reading the comments. Somebody said something about something blowing up, and I'm like, yes, let's make it explode. That goes in there. Let's set to the off position. Bench power supply is on. 5 volts, 2.5 amps. Let's turn the amps down to half an amp, just in case. Alrighty. Got hook up ground. 5 volts. And I have a light on the board. Awesome. So if I turn this on, there we go. That's very interesting. The power LED will indicate on even when the switch is off, when powered from this side, because it's on the opposite side of the power switch, which makes sense, yeah. So there we go. I hit reset. It works. Now, are we in basic? We are. No, we're not in basic. We are in the monitor. How do we get to basic? Is it 300? Is basic at 300? It says in the instructions. Uh, 300 is the monitor, which is where we code to by default. E000. E000R. No. RE. Is it? You know, I gotta type it correctly. Wow, those keys don't work. Yep. Interesting. Well, that's not functioning, but that's probably user error. Is it G or R? E300, not E. No. E000G. Nope. According to the instruction manual, it should be at yes. E000R is what the instructions say. E000R. Yeah, it's... Yep. I'm doing something incorrectly. It's okay. I know this is like riveting content watching me read the instructions. Yeah, it's supposed to be. Hit reset, right? It's supposed to hit E000R. I'm supposed to get a bracket, but I don't. Let's try putting it in AppleSoft mode, just for poopies and giggles. Not sure what's going on with that. I'm not getting the ROM to work correctly. Can't you force it using the jumper? Yes, I did. It didn't work. Are there no graphics modes? No, there are no graphics modes. Google can be your friend? Yes. Well, I have the paper version of Google right here, and it's telling me what it's supposed to do, and it's not doing the thing I'm telling it to do. Now, we could have some sort of memory fault. So, E000D, E000L, L, E000. I'm not familiar with the WAS monitor, to be honest. I'm looking at the commands. Dot. E0, no, E000 to E008. It's, yeah. That should be showing me memory, but it's not. Something is weird. And I don't know what. Like, it's sort of working. And a 4C, that's a jump. So I'm not sure what's going on. Is the ROM working? Well, the ROM's definitely working because I'm getting code. The WASMon is responding because when I give it a single memory location, it's telling me what's in that single memory location. So like if I do 301.302, it should show me, yeah, okay. So that's working. E008. That is weird. It's like not working. it's not capturing capital letters. It's not. It's, yeah. It's not getting my input correctly. Yeah. Kurt saying E000 to E0A0 should examine the first half page of ROM at that address. Agreed. Right? It's not interpreting letters. Do you see that? So 0100 shows me what's there, but OA00 is interpreting that as 0000. That is very weird. Okay, I had to toggle caps lock on and off once. Interesting. All right, that's cool. So now let's do this. Basic! Finally! Yes. It probably just doesn't like my keyboard, would be my guess. This keyboard is some ancient piece of crap I've had since 1999. So, 10, print. Does it know that? It does. 10, print. Can I get a backspace? Does backspace work? No. 10, print. Hello, world. 20, go to 10. Run. Yay! That's awesome. I have a working Replica 1 Apple I computer. So now we can do anything we want to with that, I suppose. That's kind of awesome. There's no caps lock circuit on the original Apple I. Yeah, when I turn this on, it turns caps lock on the keyboard, and the light is lit, but I had to toggle it on and off a couple times for it to interpret what I wanted. I don't know why. Thing. I don't know. But as we can see, it is functioning and working after a couple false starts. Bent pins and USB boards can't stop Joe. No, I don't give up. Yeah. Only $666.66. Yes, adjusted for inflation. I'll take your $1 million now. Thank you. But, yeah. Cool beans. That was keyboard feature. Yes. Yes, we'll call it that. How's that? Yeah, that was super fun. We went a little bit over on the schedule, about half hour over, but that's okay. Had a lot of fun doing that tonight. Wow. I'm glad you are able to stop by and hang out with me this evening. It was super fun chatting with y'all. I apologize for not paying too much attention to the chat there. I got so enthralled and buried in what I was doing here. I was like, super fun. But, you know, that's how it is. Yeah, the Apple One was not designed to work with USB. No, it wasn't. Nor were these USB connectors to work with somebody with big fat meat hooks like mine. I have big, like, mechanics hands. It's like a short, little, stubby, fat fingers. Yeah, I have a tendency to break things. Yeah, so that is how that is. Thanks again for stopping by and checking that out. Other things coming up on the schedule soon. I have a couple Apple IIIs that I have that I am repairing. They live right over here, but they're not in shot because they're right down here right now because they're in process of being fixed. I know what's wrong with them. And between the two of them, we're going to get one working Apple III. So that video is coming up soon. Stream next weekend? Probably not. Only because I don't want to compete with Kansas Fest, which is coming up this next weekend. So, yep, you don't want to... this message is held for review. It has a swear in it, but it is a relatively non-violent swear, so I'll go ahead and let that in. We're all adults here, I think. Yeah, so next stream, I've been doing this Sunday stream. It's been relatively popular, super fun. It's keeping me motivated and keeping me doing things. So I think I'm going to keep doing that. But this next Sunday, I'm going to skip it because of Kansas Fest. I do not want to even try to compete with K-Fest and the 470 people that are all going to be clommed together in one big Zoom meeting having fun talking about Apple II nerd stuff. So that's that. If you're not signed up for Kansas Fest, reach out to Chris Torrance of the Assembly Lines podcast, and he might be able to get you still signed up. There might still be time to do that. So yeah, lots of cool stuff. If you want to support my museum and buy one of these super awesome 8-bits are all you need t-shirts, or one of these super awesome drinking mugs, which is now full of lukewarm tea. Tea. Or get one of my 8-bits are all you need mugs, or anything like that, those cool little things, you can go to jcm-1.com and grab those. I'll put that in the chat for you, if I could type correctly. Oh my gosh. You can go jcm-1.com and pick those things up. Also, my lead brake kit, which is super popular right now, where you can make your own solder it yourself Apple logo. Great for K-Fest time, you know, cool little thing to do. Also, you could go to my kit.co thing and get a list of the tools that I used here today. And you know, if you're looking for some of those tools for your own kits, and you're like, well, what's Joe use? You can grab one of those tools, pay nothing extra, and I get a little tiny bitty commission on that, which helps, again, keep my shelves full and keep my bench parts on a bench and all of that stuff. John Mouth says, lead brake kit, good practice for a job like this. Yes! John, you got one of those kits. Have you built your kit? Is it did you put it together? Was it fun? I'd really like to know that. Athena Nova says, I love that print shop drinking mug. Yes. I have two variants of this mug. The one that's drinking, which is, you know, of course, the little pun. And there is another one that says thinking, of course, which is like the actual thinking. My favorite of the entire thinking series is the hat, which is called the thinking cap. And it has the logo right here, and it says thinking on it, because why not, right? So there you go. John says, yes, his lead brake kit was built. Yeah! I plan on bringing out new versions of that lead brake kit, so if you're not an Apple fan, or if you're happen to be an Apple fan but a fan of other things, maybe an Atari logo, maybe a Commodore 64 Chicken Lips logo, things like that you could do. And I'm already working on a new design that maybe will let you design your own by using an app and programming it to show whatever you want. Maybe. Don't know. I'm waiting for some parts to arrive. We'll see how easy that is to do and whether it's cost effective for that to be a little kit for people to buy. So that will be cool. He tweeted out my picture. Yeah, that's right. You're the one who tweeted. Yep. I remember now. So yeah, that lead brake kit is just, it's super cool. It's a super fun little thing you could put together to show your love for Apple II, especially this being K-Fest week. I mean, why not? Go get one. Yeah, so I really didn't have anything else to add this evening. I'm glad we were able to hang out together, get the Replica one built and put together, and work through those glitches and just have fun doing it. Amiga bouncing ball. That would be cool. I'm not sure there's enough pixel space for the Amiga ball to actually bounce, but maybe we could make it rotate. Maybe it could be an animation. I don't know. The libraries, the code, the programming, the stuff that I have in mind to be able to have the panel programmable could do animation. So maybe it can do that. I don't know. We'll find out. So again, yeah, thanks for everybody for stopping by. I really appreciate it. While you're here, hit like. If you haven't subscribed to my channel, subscribe to my channel as well. Those little things help the YouTube algorithm, help other people find me so we can have a larger nerd army to gather together, share, have fun, and do all of the super things. Yes, color rotation would be cool. Yes, it would. Well, I'm going to leave it there. Again, thanks for hanging out with me this evening. And remember, 8 bits are all you need.